Welcome back. In the previous video, we prepared the basic structure of a budget model. In this video, we'll show you how to create a budget input model in Excel reporting, so budget holders can enter their figures easily. In Excel reporting, budget entry is handled through an input model. This kind of template defines which account, people, or quantities are visible, what users can enter, what the model is meant for, which organizational unit it applies to, and for which period. There can be a company, a cost center, a department, and periods such as years, quarters, or months. The template also contains your calculation logic, so the input is processed automatically based on your business rules. Excel reporting then stores this data centrally, so you can easily use it later in reports, analysis, and of course in the next step of your budgeting process. Right now, we're working on our own template. Once it's ready, budget holders can directly enter their budget values and the model will calculate everything automatically. So the final result we want is a model with cell editors, with values that can be saved and also retrieved again, plus a save button so the figures are stored properly. At the moment, our model already has a structure in place and the data is being retrieved correctly. Now we take a step further by adding extra columns such as a budget column and a planner column, so we can really start working with it. We'll enter a budget value here and also a planner. And the planner is important because we want to spread the cost over time. As I explained in the previous video, a query consists of 3 rows: the header row, the data row, and the total row. The data row is the row that gets duplicated, so that is also the row where we want to place our calculation logic, because that logic should repeat for each line. So now we'll start by adding cell editors to that structure. We begin with the budget column. Here we want to add a cell editor. A cell editor is an input option that allows users to enter values directly in the model. Excel reporting supports different kinds of cell editors. For example, you can use one for text, for numbers only, or for a drop-down list. In this case, I want to use a pop-up table. A pop-up table opens a pop-up window, like the one shows in the example here. Inside that pop-up, you can define multiple columns, rename them, adjust them, and Excel reporting will store the values for you. That means that you can keep multiple details on a single budget line. In our case, it makes sense to include fields like description, value, date, comment, and reference. That way, you can store detailed budget information, such as the amount, a date, a comment, and a reference like an invoice number or an order number. That is very useful when you want to capture as much budget detail as possible. So we keep the same headers, value, date, comment, and reference. Then we click apply, and now we have a pop-up editor. Next, we also add a planner cell editor. A planner editor is useful when I want to distribute an amount intelligently over multiple periods. That is ideal for budgets that I want to spread over months, quarters, or the full year. It lets you apply a kind of seasonal or planning pattern to each line. So we go back to Cell Editor and choose a drop-down planner. You can either define your own planners or retrieve planners from a query. For now, we'll work with a fixed set of planners. Excel reporting already provides a list of standard planning functions, and they are documented in the support center. The planner distributes a value based on a selected planning rule. For example, it can spread €1,000 evenly across months or use another ratio if you define a different pattern. In this example, we'll create a simple drop-down list with month, quarter, and year. You can also allow users to add new planners themselves, but I'm not doing that here. So now we have 3 planners. What I also want to show is a total budget. That total budget is the sum of the current budget plus what I add in the new budget field. So that gives me a total budget value. I'll format that as an integer. And I can already enter a test value here. For example, 10,000, just to see if everything works correctly. At that point, we immediately see an issue. And that is where the next function comes in. Unwrap. What we see here is that the value from the cell editor is not stored as a simple number. It is stored as a combination of fields inside the editor structure. So if I want to use that value in a calculation, I first need to extract the underlying number. That is exactly what unwrap does. Unwrap retrieves the underlying value from a cell editor or from another wrapped cell, so that I can continue to use it in calculations. In this case, I use unwrap to extract the 10,000 that I entered in the pop-up editor. Once I unwrap it, I can use that value in my formula. Of course, unwrap can also be used for other purposes. For example, you can use it to retrieve text or other values stored inside the editor. But when you use unwrap on its own, it simply returns the numeric value inside. We will use unwrap and then later also wrap. I also convert this result to an integer. Now that we can retrieve the input value properly, the next step is to make sure that the amount can be distributed over periods. For that, we need to work with period columns. Select period. With these functions, I can connect the calculation to the period selected by the user. In this case, the selected year is 2025, which is shown in the year selection field. I use that selection to retrieve the relevant period and use it as a basis for the dynamic column headers. So first I use set period and then select period. With select period, you retrieve the period chosen in the model. With set period, you define the actual starting period. So, for example, the first period of the selected year. You can also use that starting period in further calculations if needed. Once that start point is in place, the next step is to extend it dynamically. And that is where add period comes in. Now I want to make the period structure dynamic. For that, I use add period. With add period, I can keep moving forward relative to the period I started from. So if I start with the first period of the selected year, I can use add period to generate the next periods one by one. And that is how I create dynamic period columns. So instead of hard coding each month, the model builds the columns automatically based on the selected year. That means that if I switch the year from 2022 to 2026, the period columns update automatically as well. That is exactly what we want, because the planner will use those periods to distribute the budget over time. So now that the dynamic period columns are in place, we can move to the planner function itself. Now we use the planner function to distribute the budget amount over the periods. The idea is simple. I take the value entered in the budget column and use the selected planner to distribute that amount across the months or other periods. So the planner function works with 3 main elements: the input value, the selected planner, and the index of the period being calculated. The function itself is documented in the support center. What it does is it distributes a value based on the proportion defined in a planner. For example, if I have 1000 euros and I choose a monthly planner, then in month 6 I get 1/12 of that amount, if the planner is evenly distributed. If I use another planner, where month 6 has a higher weight, then the function takes that ratio into account and returns a larger share for that month. To do that, I first use unwrap again, because I need the actual entered budget value. Then I choose the planner as the second parameter. And then I define the index that tells the planner which position it is calculating. In this case, the index is based on a month number. January is 1, February is 2, and so on. I use the month function to return that number. At first, if no planner is selected, the result is 0. But once I choose a planner, the amount is distributed correctly. I can then copy that formula across all period columns. To prevent the references from shifting, just like in a spreadsheet, I fix the references before copying. Now, all period columns use the same formula logic. If I switch the planner to quarter, the distribution updates. If I switch it to year, it also works correctly. So now the calculation is working. At this point, the model is almost interactive. The only thing still missing is saving the entered data, and that is where the import query comes in. To store the entered values, we create an import query. An import query writes the entered values back to the database. That turns this model into a fully working budget model. So we go to Define and add a new query. We call it Save Work Data, and this is an important query. I choose the mode Replace because with Replace, existing values are overwritten with the latest input. That is useful when budgets are revised and resaved. Since I want to store the data in Work Data, I select the dataset Work Data. This name is just a convenient label, but I like to keep it simple. Once I click Apply, I enter the definition of the import query. Here, I define how the save action works. What we do here is map the columns from the model to the fields in the target datasets. So first, I define the target fields. For company, I use the selected company. Then I also want account name, although I later want to refine that, so I only store the general ledger information. For company, I use the selected company. Then I also want account name, although I later want to refine that, so I only store the general ledger account information and not the full display name. We are not using cost centers or projects here, so I leave those fields empty. For version, I want to store the values as budget plus the selected year. That means I use the selected function, which allows me to reuse values that were selected in the model. In this case, I use a selected year from the year selector. Then I define the source, because I want to know from which model that this data was stored. Since we already have another profit and loss planner, I name this one Planner 2. For item, I use the account key, because I'll need that later to retrieve the data again. The settings field stays empty. For work data itself, I use wrap. Wrap packages values back into a structure, so they can be stored correctly in editors and import logic. Here, I choose the fields I want to store, which are the budget field and the planner field. Those are the editor values I want to save, so I can retrieve them later. Next, I also want to make sure the item key is robust. I do not want to use a full account name as a lookup key, because if the name changes, the lookup key changes too. So instead, I use concat and split to build a more stable key. With concat, I combine the selected company and the account information. But because I only want the account number and not the full account name, I split the account text and take only the first part. I do the same for the item field, because in this example, that key follows the same logic. And finally, I define the replace criteria. These criteria tell Excel reporting which existing data should be replaced by new input. In this case, I want to replace to use company, budget year, and source. So if those match, the existing record is replaced with the new values, and that completes the save action. After saving, we can already test it. The test values are stored correctly. But although the data is now saved, it is not yet being loaded back into the model. That is the next step. To load the saved values back into the model, we create a query on work data. This will be a data list because we do not want to display it directly in a report. We just want to use it as a source to retrieve the stored values. Since this is a second query, we do not create the same selection fields again. Instead, we can reuse the existing selection fields with the selected function. So again, we use the selected year and the source name to identify the correct data. At this point, the query retrieves work data records, but work data itself contains two wrapped fields, budget and planner. So to show them, we need to unwrap them. Unwrap allows us to pull out a specific field from the wrapped value. In this case, I know the first wrapped value is budget and the second is planner. So I unwrap both. I do not place them in numeric values area because they are not always plain numbers. If I did that for text-based content, the model would simply show 0. After applying this, I can see that the work data query is now retrieving the values correctly. So the data is being loaded, but the cells in the model still do not know how to use that data because it prevents the formula from accidentally returning the first available value from the query. For a budgeting model, I find dget-A the safer option. So I temporarily remove the cell editors to make room for the formulas. Then I use dget-A to retrieve the budget value from the third query. The value I want to retrieve is budget. The lookup is based on account name, but because that field contains both name and number, I split it. So the lookup uses only the account number. When I test with account 6000, the stored budget value is returned correctly. I then notice that the item field still contains the company prefix, so I split that as well to keep only the part I need. Now, the lookup works correctly. I then fix the formula references and copy the formula. For the planner field, I do the same thing, but now I retrieve the planner value instead of budget. That way, both the budget and the planner are restored from work data. The model retrieves its data correctly and I can save it again. So the work data loop is now complete. At this point, the model is functional, but I also want the distributed budget values to be stored directly in the financial dataset. And that is where the import query for balances comes in. Because the model contains multiple period columns, I use transposed data. Transposed data turns columns into rows, so I can store each period value as a separate record. I only apply that to the period columns. Once the data is transposed, I define the same key fields again, such as account name, version, and source. Version again becomes budget plus the selected year, Source again becomes our profit and loss planner 2. For period, I do not select a fixed period field. Instead, I use transpose name because that contains the original column name, which in this case is the period name. And for the account itself, I use transpose value. Description is not needed here, and the rest can stay empty. For replace logic, I again define keys such as company, budget, and profit and loss planner. I also make an exception so that if account name is empty, for example for subtotals, the record can be skipped. Another useful option here is to keep the query silent. That means that when I click Save, I do not need a separate confirmation message for every query. I can choose one main save query to display a confirmation and keep the others silent. So I enable Keep Silent for this one. Now I save the query and test it. The model already contains input, so when I press Save, I get a green confirmation message. That means that values are being written to the database. To verify that the save worked correctly, I can go to Action and choose View Saved Results. There, I can see exactly what was saved. For example, I can see how many rows were saved through Save Data and how many rows were saved through Save Balances. So, what have we done in this video? We created a budget input template in Excel reporting and turned the model into an interactive budgeting model. We added pop-up and planner cell editors, used unwrap to retrieve entered values, created dynamic periods with set period and add period, distributed values with the planner function, saved the editor values to work data, retrieved them again with dget a, and then also stored the final budget values directly.